imaginary number. So a complex number means it has an imaginary part. It's complex because it has two parts. It has a real and the imaginary. So we're just learning how to deal with these things. And they work very similarly to variables and square roots. So there's nothing new in them. You just got to know how to apply it. First thing you have to know is the definition of an imaginary number. So when you have x squared equals negative 1, and you're solving for x, you take the square root, correct? Mm-hmm. Well, if you take the square root of negative 1 on your calculator, you get error or syntax error, something weird. Okay, if you do mine, I think it actually gives you an answer. It should give you an answer, but you don't know what it means. So square root of a negative 1 is imaginary by definition. This is definition. And that means I. Okay, what else would give you an imaginary number besides a square? Careful, will a cube give you imaginary? Cube is totally legal, because can I take negative 1 times negative 1 times negative 1 and get negative 1?
No.
Yes. 3 negatives gives you a negative. So a cube or to a fifth power, they'll always work. They're always real numbers.
So like even.
It's the even one.
It's the even ones. When you have an even exponent, you're going to get imaginary. Are we going to be working with the 4s and the 6s and the 8s? No, we're only going to be working with the squares. That's all we're going to be doing, but realize they do exist. Okay, when you're here, there's a pattern to imaginary numbers, and you have to know what it means. Descartes is the one who invented them. He's actually crazy too. You can look him up if you want. Okay, by definition, what I want you to know is what's over here. Okay, where the answers lie. Well, by definition, I is the square root of negative 1. Good? That just means I. That's definition. That one has to be memorized. Now, I have to figure out what every other power of I is. So if I give you any power of I, you have to tell me what it means. The part about I that's a little weird is they're not all imaginary. Okay? So just because you have an I, it does not mean it's an imaginary answer. You have to be careful of what the exponent is. So when I go up here, I squared, well, that means I'm really squaring the square root of negative 1. Well, what does square and square roots do to each other? They cancel each other out. So now you have I squared equals negative 1. So I squared is a real number. It's not imaginary. Good so far? Okay, now we're going to use all of our i's to find these things. Now I need to find I cubed. By your rules of exponents, you know that I cubed is the same as I squared times I, right? 2 plus 1 is 3. So I can use I squared and I to the first, or these two. Okay, so far. So I squared is negative 1. I is I. Well, negative 1 times I is negative I. That means I cubed is negative I. It's imaginary. Good so far? It's math.
Well, I just really don't get that. How is it negative I?
Okay, what's I squared?
I squared is negative 1.
Okay, and what's I?
I
is I by definition, right? What's negative 1 times I?
Negative 1 times I is negative 1.
That's why I cubed is negative I. Because we broke it down.
So I squared is negative 1.
I squared is negative 1. That's the two you need to have absolutely memorized. Are that I equals I, and I squared equals negative 1. If you know those two, you can figure anything out. Got it?
I equals I.
These two are the most important.
Yeah, is it like I as in I love you, or I as in my I hurt?
I is in imaginary number, neither one. I is in math class. But I love you too. Okay, I to the 4th. Okay, I to the 4th, I can break it down many ways, right? It can be I squared, it can be I cubed in I, it can be lots of things. I like using I squared because I squared is negative 1. Doesn't get any easier than that, right? So I use I squared and I squared because 2 plus 2 is 4. Good to there? Well, I squared is negative 1. So negative 1 times negative 1 is 1. So I to the 4th is a real number. It is 1. So, any patterns so far that you see?
Okay.
If it's a negative, or if it's an odd,
I to the 8 would be.
Break it down into squares.
oh, never mind.
It
Is that
would.
bad?
It's part of it.
That's every fucking.
It's like we
So-
say 4 exponents.
Everybody said.
He said I to the 8th is going to be 1.
So we have a
But I to the 6
Right.
will not
How
be.
that thing isn't.
So, well,
I don't know.
So we have
Okay, you have 4 of them to figure out. Use your partner if you like. Figure out what they equal, find the pattern.
do you want us to like, so you want us to break it down into I squares?
You can do whatever you like. If you like I to the 4th, use I to the 4th, because I to the 4th is 1.
They got an I button on the calculator.
Yeah,
Where?
you don't know how to use it.
Well, how do we use it?
It won't help you out in here, because it's going to tell you how to graph on an imaginary axis, which you have no idea what that is.
This has no
That one does not. It has to be the higher up one.
You lose it.
Okay, go, find yours.
Use it. I think.
There's 2 I squares. And then there's an I. So it's just an I. So what are the sides?
No, good.
If your name's on the board, you owe me stuff, get it in. I have call duty this week, so if you wanna work with me out in the hall, you can after 8 or get in here
Plenty of
before
actually
8.
up there.
Wait, Craig's
No.
in 3rd period though.
Okay, you said Coach Lewis.
Craig's in second period, but he's on his second period.
Because I squared. I do. Dude, I swear. This is like
I was 6
I squared. I squared. So then,
I was 6
so it's negative 8.
Okay, I couldn't find either.
And then
And it's like, it's called like,
no, it's negative. If you have an I, it's just an
I mean, might make sense. I'm thinking when is someone going to use I?
Alright, what's your pattern? I to the 5th is? Okay, I squared, I, which is -1, -1, I, which is I. I to the 6th,
But you have two.
because she used I squared instead of I to the
But
4th.
you have a 1 and a negative.
That's a negative.
No, it's a
It's a
negative
negative
one.
one.
Oh, I see it now.
Okay, I to the 6th,
Negative 1.
-1, because we could use I to the 4th, I squared, right? 1 times -1, -1. I to the 7th, negative I. I to the 8th, 1. What's my pattern?
I, negative
No, what's my pattern? What's it
Negative one,
doing?
negative
In
one,
words, it is
I-
what every what?
I every
It's a
It's
negative
what?
I every 2 exponents.
It repeats
every 4 times.
every 4 terms. So, if I give you something ridiculous, like I to the 135th,
Whoa.
what do you have to do?
Start breaking it down.
Into
4
I squared,
terms.
I squared.
4, groups of 4, so what do I have to do with the 135?
Divide
Divide by four.
Divide by 4. What part of that answer do I care about?
The exponent.
the decimal.
That's
The remainder,
so it's 0.75.
which is a remainder of what?
3.
3. So if I take 135,
So it's negative I.
yes, divide it by 4,
Man,
I get,
genius.
what is it, 33.75. That means 3/4, which means I have a remainder of 3.
Negative I.
So that means I cubed, which is
Wait,
a negative I.
3/4 is your 3 is the remainder?
Yep. Let's go little division. Remember when you were little? 135 divided by 4? And that gives you a remainder of 3. IQ, which is negative I. Logan, what's a remainder of 0? Answer.
1.
Yes, why?
I'm smart. I don't know, I guess.
I figured you did.
Well, I would assume because 0 or 1 equals 0 equals 1, I don't know.
Isn't like the square root of 0
No, if I have a remainder of 0, the answer is 1. That's because when you're up here, guys, look at your eyes. This is I, remainder 1, right? Remainder 2, remainder 3. Well, that's remainder of 4. Can you have a remainder of 4 when you're dividing by 4?
That'd be all.
So this is remainder,
1.
no, of 0.
So it'd actually go 2, 3, 4, 1.
What?
No, it goes.
It'd be
1, 2, 3, 0.
There's not 1.
So it'd be 25, 50, 75, double 0.
Yes.
I just remember
No,
0.
just break it.
All right, Logan, what's I to the 32nd?
24. Hold on.
What do you do with 32?
Dude, the answer is 1.
The answer is 1. Because 32, quiet, 32 divided by 4 is 8, remainder 0. Remainder of 0 is
1.
same as I to the 4th, which is 1.
Remainder.
What part?
The 0, and then you still get a remainder of 1.
No.
Get a remainder.
It's not a remainder of 1. It is 1. Because I to the 4th is 1. It's not a remainder. It is. Are we getting there? Okay, what's I to the 83rd? No, 82nd.
Negative 1.
Negative.
Negative I.
Negative I. Because 80 divided by 4 is a remainder of, 82 divided by 4 is a remainder of 2. Remainder of 2, 82 divided by 4. So 0.5 is a remainder of,
Negative 1.
what's half of 4? 2. So it's remainder of 2.
So
So
if
I
it's 2,
squared.
why is it not?
I squared is
Negative 1.
negative I. Or negative 1.
Yeah.
Okay, are we getting it? Okay, next. Now you're going to use this here to break down problems. And it's really simple. I showed you the long way. If you can go straight from the problem to the answer, I would be extremely happy.
Don't worry.
Really.
So
But what you're doing, like I would never do this. Okay, what you're doing is you're breaking this down in your head. So I'm taking the square root of the number, 81, the square root of a negative, negative 1, and the square root of the variable is what you're looking at. Well, the square root of the number of square root of 81 is just 9, right? The square root of negative 1 by definition is I. Now you have to remember the square root of x cubed. When we first learned this, I made you draw out how many x's there were, right?
Mm-hmm.
And you said there's 3 x's, and I'm looking for groups of 2. So that means 1 comes out and 1 stays in. So it's 9x square root of x. Can you do that in your head?
Yes.
Yes. You don't have to, but you can. Okay, get yours done.
I'm done.
Check with your neighbor. So we've got 11 from the 121.
Yep.
I from the negative.
Yep.
X to the 5th means I have 2 whole ones
Yep.
with 1 remainder. Everybody good? Yes and yes?
Yep.
Okay, now this problem right here is where most of my mistakes will come. Hopefully not. Okay, because you're going to do what you've always done with square roots. So when you see a square root, you multiply what's underneath, right? What's a negative 5 times a negative 20? 100. So you're going to say, hey, that's the square root of 100, and the square root of 100 is 10. You have completely ignored your imaginary part of your answer. So you're wrong. Okay, so to do this, your first step is to always take out the imaginary parts and then do what you've done before. So we take out the I from the negatives. I don't even care about the numbers right now. Irrelevant. So I got I square root of 5, I square root of 20. Everybody okay? Now do what you've done before. You multiply the numbers, you multiply the I. So I times I is I squared. 5 times 20, 100. Well, what's I squared?
100.
No, what's I squared? Negative 1. Square root of 100 is 10, so your answer is negative 10. Do you see where your mistake would have come?
Yep.
Yes, be careful. Okay, this one here is, how do I multiply? Go. Should be about done. That's quick. What do you got? Okay, this is what Zach told me. He's not wrong, but he's not right. 24i squared. You're so close. Are you done?
No.
What's I squared?
Negative 1.
I squared is negative 1. Good. Good?
Will you take
Probably. If you
points
gave me
off?
the I squared. Just didn't do the last part.
That's whack.
Okay, now, we have x squared plus 81. Before, you would have told me that was unfactorable and you could not solve because it was not a difference of squares, right? The difference of squares is x plus 9 and x minus 9. Life would have been 9. But now that we have our imaginary part, we can solve this. So I subtract the 81 and I take the square root. Well, the square root of a negative is I. Square root of 81 is 9. All square roots have a plus and minus. Done. Questions?
No.
Okay, yours is about the same thing, except I want to make sure you remember how to reduce radicals, so you have to reduce to 72. If you don't look for perfect squares, you're doing factor trees. Go. Okay, what did you break it down to? Did you break it down, or did anybody recognize that's 36 times 2? 30, a perfect square that goes into 72 is 36, right?
Right.
So the square root of 36 is 6. So it's 6i square root of 2. Done. If you recognize that, good. If you didn't, you broke it down. What did you do?
I broke it down.
You broke it down into what?
36, but I didn't see the 36.
See, now, if you saw that, you were finished. Because the square root of 36 is 6. Okay, if you did not see that, and you still didn't see it? Oh, Lord.
It's been a while.
It's been a while, huh?
I just kept going twos.
All right. So then we have a group of 2 and a group of 3. So 2 times 3 is 6. Negative tells you I. Plus or minus square root of, what did we not circle? 2. That's it. Everybody happy? Okay, adding and subtracting. When you're doing these, they're called complex numbers because they have 2 parts. They have a real part and an imaginary part. Okay, the real part doesn't have an I, and the imaginary part does have an I. That's how you tell the difference. So they're not always in the same order. Mathematically, they're supposed to be written real, then imaginary. That's how it's like in descending order. It's always real, then the imaginary part, but they're not always. So, the real part, no I. Imaginary part has the I. Good? When you're adding, you combine like terms. So it's real plus real, imaginary plus imaginary. So when I go down here, like I don't do this. I say this is 8 minus 12, negative 4. Real and real. Good? Imaginary, 7i plus 11i, 18i. And you are done. Makes sense. Okay, why is yours a little trickier? It's subtraction. So make sure you deal with that negative sign. Go. Check with your neighbors when you're finished. What was the answer?
Negative 3 minus 8i.
Beautiful. Okay, here, when you are multiplying, it's just like your distribution from before, or your FOIL method. But you have to be careful. You know how we always got 3 terms, right? Your x squared, your x, and your number. Well, we're gonna have an I squared, but what's I squared?
Negative
Negative 1. So how many terms will I have when I'm finished?
2.
Only 2. So you distribute just like before. So 16 minus 24i. Everybody good? Yes?
Yeah.
10i minus 15i squared. Okay, but what's I squared? Negative 1. So I squared is really negative 1, so this is truly plus 15. Good? If you want to go up here and say I squared changes the sign and skip this step, that's fine. Okay? Now you combine like terms. The first term and the last term are real, so they go together. And I have one imaginary, so we just write him down. Questions? Makes sense. FOIL, combine like terms, I squared equals negative 1. Go. You have 2 practices. Make sure you get them both done. Go. Quiet. See how he does.
Well,
Oh, no, it's you.
You can just take like a first step like this.
yeah.
Just like this.
Yeah. I take a big
Code.
Fine, you're up next.
She would be on this.
That's supposed to be negative 24 plus 28i. Beautiful. Well done. Okay, the next one. I gave you a clue. I told you what was a conjugate. Conjugates we've used in the square roots, remember?
Anybody know
And
what
we
that
use
is?
them to clear the square roots. So when we had a conjugate, did we have to do all the math? No, because the middle terms always do what?
Cancel out.
Cancel out. What's the matter?
Oh, I was just taking a look at it, helping them.
So we take 4 times 4, which is what?
It's 16.
16. So this is what I could do. And 3i times a negative 3i is what?
And then negative 9i squared.
Negative 9i squared, which means that's 16 plus 9, which is 25. If you did the whole FOIL, 16 minus 12i plus 12i minus 9i squared. The 12i's cancel. So does it hurt to do the whole thing? No. Is it just extra work? Yes. All good? Remember, conjugates clear middle terms. Because just like square roots, we cannot have conjugates in denominators. Now, this is not a hard and fast math rule. This is one that I use because it always works and it makes life easy. When you're finding the conjugate, you always change the sign of the imaginary part. That's it. So if I give you negative 3 plus 4i, right here, the imaginary part's the 4i, so I change him from a positive to a negative. Are there more than one way to do this?
Yes.
Do they mess up negative signs?
No.
Generally. Will this one always work? Yes. So if I gave you 5i, just a straight 5i, what's its conjugate?
Negative 5i.
Negative 5i.
You, move out.
If I gave you 3 minus 2i, what's his conjugate?
2i.
Oh, you can't leave the 3's. 3 plus 2i. You just changed the sign of the imaginary term. Make sense? So here, I take the 2 conjugates, the middle terms cancel, I squared becomes positive, done. Good?
Yeah.
Okay, go. Write the conjugate, tell me the answer. Got it done? 16 plus 25, 41, yes.
Let's get this one, Polly. Heart attack, Polly, then.
Harder, go put it up.
Okay. Where's the red balance of blue?
Everybody good? Do we have? Okay. Everybody got 41? Happy? Okay, next. Okay.
Oh, you know what that means?
Oh, it's all gone.
Yeah, he's me.
If you hit X, do not hit X. It'll wipe out your whole computer.
No! Still recording.
Oh!
Oh, come on.
It's gone. It is gone. I heard if someone dies doing the body scan test.
You're all getting it.
Yeah, you heard that too.
Hey, what's taking time?
Why me?
Okay, where were we? We just did.
Right up there.
It's 5 division.
Right here.
All right.
Conjugate part.
We just did that one, all right? All right, now in division, i's are just like square roots. You cannot have them in the denominator. And just like a square root, in order to clear them, we use the conjugate. But whatever you do to the denominator, you must do to the numerator. So will the numerator have more work? Yeah, you're going to have to do the complete distribution. Where the denominator, you can cheat. So if I have 3 plus 4i on the bottom, I have to multiply by 3 minus 4i. But whatever I do to the denominator, I must do to the numerator. The bottom is a simple conjugate, so you can do the 3 and the 4i. You don't have to do that step. And you've now got 25. The top, you have to do all of it. So you have to take the 5 times the 3, the 5 times the negative 4i. Everybody good? And then the negative 2i times the 3, and the negative 2i times the negative 4. Remembering that I squared is what? Negative 1. So when you get down here, this cancels from an I squared to a negative 8. Everybody see where it came from? 15 minus 8, 7 minus 26i over 25, and that's reduced. Your turn.
What is it done?
You got that?
So I'm either working ahead
You
or
have 7
How do I get rid of this?
Some people are just like buses.
Kind of looks like it, doesn't it? Okay, we're multiplying by the conjugate, which is 4 plus 5i, numerator and denominator. What do we get on the bottom? 16 plus 25, which is 41. Okay, the numerator, what do we have? Negative 12
I plus 8i
minus 15i
plus 8i
plus 8i plus 10i squared, which means this becomes minus 10. Okay, negative 12 minus 10, negative 22. Negative 15i plus 8i. Done. Questions?
Whoa. Whoa, Nelly.
What? I heard that side not go away. All right, when you're doing imaginary problems, what you're doing is you're setting the real part to the real part, and you're solving for x, and the imaginary part to the imaginary part and solving for y. On your problem, practice problem, I forgot to type the y in. So where it says 3i, that's supposed to be 3yi, so put a y in there. Okay, when you solve, you set real to real. So the real part on this side is the 3x. What's the real part on the other side? 15. So it's just 3x equals 15. Divide by 3, x equals 5. Okay, now the imaginary part, I'm going to set the 5y equal to the negative 20 because they're both imaginary. Is everybody with me?
That's all you need.
Yep. Divide by -5, and you're done. If you write the whole thing out, -5yi equals -20i. When you divide, you'll be dividing by the -5i, and the i's are going to cancel. You'll still get the same answer. Both ways will work. It doesn't matter which one you use. Is everybody good? Yes, there's supposed to be a y by the 3. Okay, do your part, and then we'll graph.
How about me?
Okay, what'd you get? X is equal to 2, y is equal to -2. Good. Okay, next, graphing imaginary.
Yeah.
All right, it's just like graphing a point or a line. What they do is they change the name of the axes. So the X is the real, and the Y is the imaginary. So all they did, the real used to be the X-axis. The Y is now the imaginary. And you graph it the same way. So if I give you 3 plus 2i, this is on the X, and this is on the Y. You graph it like a point. So you go over 3, up 2, put it out. Done. Good. Question. All right, you have 4 problems to do. 2 of them are tricky. These are 4 different problems to graph. Let's see if you can get them. Maybe. Okay, -3 plus 2i. How did you graph it?
Go left 3.
Left 3, up 2. Okay, there you go. How did you graph 7?
Go right 7.
A vertical line.
And you put a dot, right? And 4i, you went up,
Or
and you put a dot. 5 minus 3i?
Right 5, down 3.
Right 5,
Ding,
down
ding.
3.
Okay, these 2 are good. These 2, this is really a line. Because this is 7, well, so is this, and this, and this, and this. All of those are 7, right? So this is technically a line. I would probably take your points and only yell at you a little bit. But you should know that those are lines. Questions? Yep.
No. Homework.
Yeah, I think it is homework. And I forgot to write it all up there, so I gotta read it.
Yeah, go to school now. Heard the storm coming, so.
Okay, get going.
No, you can't pack up early.
I'm not gonna pack that, it's just saying.